Hey physics. Okay, so this is a walkthrough of part 3 of the unbalanced forces and acceleration practice problems slideshow. Looks like this. So we did do this in first hour, I think, but then we didn't do it for fourth and sixth hour, so I'm going to just walk you through this real quick. Okay, so a cyclist has a mass of 50 kilograms and is accelerating at 0.9 meters per second squared. What is the size of the net force acting on the cyclist? Okay, so for this, we're solving for the F net, the net force. So F net equals, and that's going to be mass times acceleration. All right, so let's fill in the numbers here. Here, let's copy and paste this over here. Okay, so F net, the mass is 50 kilograms, always using units. Acceleration is 0.9 meters per second squared. Just copy that. And I'm going to make this a little bit smaller. There. Okay, so all I need to do there is 50 times 0.9. So 45 newtons. See how I did that? So I'm using this triangle to just move that equation around the way I need it. Let's see. Next one. A car has an acceleration of 4 meters per second squared and a mass of 800 kilograms. What is the net force on the car? So again, I'm doing the equation for F net. So I'm going to copy and paste this. There. Okay, I'm going to show my work there. So, paste. Let's make that like this. Okay, so the mass of the car is 800 kilograms, and the acceleration is 4 meters per second squared. And remember, another way you can do that square is special characters, sup for superscript, and just press the number 2. Nope, it didn't work. Oh, because I was looking in the wrong spot. Sup 2. Okay, and I'm going to make this, hold on now. I'm going to move that to back. There we go, that should work now. Okay, let me make this a bit smaller. Okay, so 800 times 4, so that's going to be 3,200 newtons. Okay? Let's try this one. A truck with a mass of 5,000 kilograms is traveling at 15 meters per second when it brakes, suddenly skidding to a stop. There's 6,000 newtons of net force acting on the truck when it is braking. What is the acceleration of the truck? So this is that same equation, but we're going to rearrange it. So first thing we need to do is we are solving for acceleration. I wish it wouldn't autocorrect those. Acceleration equals F net, and since this is F net is above mass, I'm going to do F net divided by mass. So the net force acting on the truck is 6,000 newtons. I'm going to copy and paste this, and then I'll just fill it in. Copy. Okay, so F net is 6,000 newtons, and the mass is 5,000 kilograms. So, easy peasy, I'm just going to do 6,000 divided by 5,000. Okay, so 1.2 meters per second squared. But here's the thing. I know that this truck is skidding to a stop. So if I write 1.2 meters per second squared, that means it's getting faster. I need to write negative 1.2 meters per second squared to show that each second it's it's traveling 1.2 meters less than it was the second before. So negative 1.2 meters per second squared. Okay. So, yeah. Okay. Yeah, and remember, negative acceleration is the same thing as deceleration. Okay. You give a shopping cart a shove down a smooth floored aisle. The cart is full of groceries and has a mass of 18 kilograms. The cart accelerates at a rate of 3 meters per second squared. What is the applied force you exerted on the cart, assuming the floor is frictionless? Okay, so let's see what happens when I paste here. Okay, that's not the one I need. So we're looking for the F net equation. So I'm going to grab that from up here. Okay. So we are looking for the applied force, assuming the floor is frictionless. So that's going to be F net. So the mass of the cart is 18 kilograms, and the acceleration is, I'm going to just copy this, 3 meters per second squared. This whole thing a little bit smaller so it all fits on one line. Okay, so 18 times 3 is 54 newtons. Okay, so just a couple more here. All right, so now we're looking at a parachutist that is falling through the sky. Two forces act on a parachutist during a drop. One is the force of gravity, felt as the parachutist's weight. The other is the upward force of air resistance on the parachute. The parachutist has a mass of 50 kilograms. So there's a couple steps to this problem. So the first part is figuring out where those forces are. So gravity is pulling that parachutist down with a force of 500 newtons, but their air resistance is pushing up on that parachutist with a force of 400 newtons. So the net force acting on this parachutist is going to be 100 newtons downward. And I did that by doing 500 newtons minus 400 newtons. Because that 400 cancels out 400 newtons of the downward force. So we're just left with 100 newtons. 100 newtons downward. So now we're going to figure out how much and in what direction is the acceleration. So we're solving for acceleration. So let me grab that equation from up here. All right. So I know that the net force here is 100 newtons, because I found that here. And the mass of the parachutist is 50 kilograms. So easy peasy, I can do this in my head. 100 newtons divided by 50 kilograms. And remember, sometimes it seems weird working with these different units, but if you'll remember, newtons actually stands for, newtons has all of the other units wrapped up in it. Newtons means the amount of force that it takes to push 1 kilogram of mass, or to accelerate 1 kilogram of mass by 1 meter every second. So that's why we can do this with these multiple units, all lumped together. Okay, so really that is 2 meters per second squared. But if I'm assuming that my upward, that an upward motion would be in the positive direction and a downward motion would be in a negative direction, this is going to be negative 2. Nope, actually that's wrong, because that would mean that there'd be 2 meters per second less every second. So yeah, they're still going downward faster and faster every minute, every second. Ooh, I want to check on this one. Now I'm like questioning myself. Anyways, 2 or negative 2 meters per second squared downward. Downward for sure is what we know. I will check on that and get back to you. Okay. A shopping cart and its contents have a mass of 20 kilograms. The cart is pushed with a force P across the rough pavement of the parking lot. The friction force acting on the cart is 20 newtons. The acceleration of the cart is 0.5 meters per second squared. So how much net force is acting on the cart? Okay, so the net force is the combination of the amount of pushing that is canceled out in part by the friction force, right? So we're going to use this F net equation to solve this. So I'm going to copy and paste this here. So the mass of the cart is 20 kilograms, and the acceleration of the cart is 0.5 meters per second squared. Okay, so pulling up my trusty calculator, I'm going to do 20 times 0.5, which is 10 newtons. 0.5 means half, obviously, so half of 20 is 10. Okay, so now that is the net force that's acting on the cart. So we still need to figure out what P is. So what is the size of the force P applied to the cart? So to solve that, what I'm going to do is, I'm going to use this equation here, which just is kind of like a mathematical way of showing that these two forces are like canceling each other out. So force number 1 is P, well, okay, so our F net is 10 newtons, right? So we have P minus 20 newtons. So we can do this algebraically. You could rearrange it all fancy style, meaning you could do like plus 20 on both sides, right? Or you can kind of just look at it and do it in your head. So something minus 20 is 10 newtons. So something minus 20 equals 10. So that's going to be 30 newtons. So I need to push with a force of 30 newtons to overcome this 20 newtons of friction force and push that cart forward. That's what's going on there. Okay? So a couple steps there, but you could do it. Okay, so here's another one. Mrs. Allen's son, Calyx, and this is really Calyx, he's super cute, is pushing his cousin Sophie on a tractor. The mass of Sophie and the tractor is 14 kilograms. Calyx applies a force of 110 newtons because he's super strong, and the tractor accelerates down the driveway at 2.86 meters per second squared. What is the force of friction acting on the car from the driveway? Okay, so first step that we need to do here is to figure out how much net force is acting on the tractor. So we know the mass and we know the acceleration. We know how much force Calyx is applying, but we don't know how much friction is acting there. So let's do this one to find the net force first. Okay, so the net force is going to be the mass, which is 14 kilograms, and the acceleration is going to be 2.86 meters per second squared. Okay, so easy peasy there. We're just going to do 14 times 2.86. So we'll call that 40 newtons of force. Okay, so that's how much force is actually moving the tractor. But Calyx is applying 110 newtons of force to try to move it. So how much is the force of friction? The force of friction is everything that's not, or everything that's canceling out Calyx's force. So he's actually able to move it forward. Oh gosh, this is about to die. See if you can figure this out.